Okay, good afternoon to all of you and welcome to the webinar VOC Optimized Binder Systems for Reducing Pollution During Core Production and Storage, brought to you by ASK Online Academy. I'm Thomas Glattis, Head of Business Line Management EMEA, and I'm excited to kick off this webinar, which will offer you insights about VOC emissions in the foundry process and possibilities to actively reduce those emissions with different measures. You see my colleague Frank Lenzen in the picture on the left side. He is the speaker of today's webinar. Frank is Technical Product Manager for CodeBox in EMEA and expert in the field of VOC emissions. First, I would like to go through some organizational topics. Your name and pictures will not be shown due to data protection policies. You can ask questions via the chat function on the bottom right of the webinar screen, and we will try to answer all of them at the end of the webinar. If we don't have enough time, we will come back to you via email afterwards. Then I would like to continue with the leading questions of today's webinar, which are significantly driven by the increasingly higher emissions regulation standards, as for example, TIA Luft in Germany or similar standards in other European countries. VOC reduction is in the meantime a topic which almost all foundries are working on, and we are getting many project requests across Europe where our customers are asking for technical advice to support them to be able to comply with the updated regulations. So the leading questions for today are: what are the key sources for VOC emissions in the foundry process, and what are the current emission regulations from the different countries? And secondly, how can foundries actively reduce the VOC emissions to a level so are able to comply with the current and potential future emission regulation standards? Next is a brief overview of the agenda. The agenda points are: why is VOC relevant? What is the VOC definition? Then we're talking about measuring. How can we measure this? We will give some customer examples and some technical solutions, and then we will close with a conclusion. So good for my introduction. Then I would like to pass on over to Frank.
So thank you, Thomas. Thank you for the introduction. So I will start to discuss about why is VOC relevant. What is it all about? What's the problem with VOCs? So this is a small sketch, an overview about emissions which can happen during the casting process and which are relevant in different countries. In most cases, there are limits for BTX, for example, or formaldehyde. All the different substances and themes are somehow relevant for the so-called VOC, volatile organic compounds. So you start on the left corner. VAT guidelines in Europe is the start of everything. BAT means best available technology, and this BAT is a European Congress, which is organizing a questionnaire, which then is sent to the particular industry, asking for what technology are you using and what is finally your emission level. Target is to reduce the emission of all industry level. So finally, after these statistics they're done with this data out of the questionnaire, there's a so-called BREF paper produced, best available technique reference document. This is a guideline for the EU law, and then later on for the national law and guidelines, which the TIA Luft is one of those in Germany, which is regulating then all the emission levels, and is the guideline for the government. And this is then finally to lead to values you have to be within. On the other side, you have worldwide initiatives to reduce emissions. Most is CO2 reduction, but also the other parameters are worldwide target to reduce. And then you have also public pressure, like I think all of you know Fridays for Future, the young people which are pushing that environmental friendly technologies are more and more in the market. So let's start with the CO2 emissions. This is more or less known from everybody. You know that in a lot of countries, CO2 is a target to be CO2 neutral. In Germany, for example, in 2030, in the different sectors, this is more or less known from every one of you worldwide. And but what is not known is the next theme. This is the so-called VOC emissions. VOC is the same thing with the CO2. We want to reduce the VOCs, all the organic compounds which are released during a production process, because they're all some correlation with environmental issues. We have here the process in Europe and in Germany, which we have to follow to finally have these values of 150 milligrams carbon, which is defined in the so-called tier luft. Let me start at the beginning. So first of all, we have a questionnaire which is made from this commission in Spain, this BAT commission. They're asking for the technology you use, the emission level you use. So they're starting a benchmark of these emissions and technologies, a statistical process. So let's say we have 100 of foundries and 100 of results. They look for the 80% with the best values. Example, let's say we have one foundry which is using amine, and usually amine is not allowed to release free in the environment. So you have to use sulfuric acid washer to wash the amine out of the air. One foundry has this washer. You have low values after the washing process. Everything is okay. This is technology state of the art. In England, for example, it's not EU anymore, but anyway, they don't have, in the most cases, an amine washer. So they release the amine directly in the air. So this is not technology state of the art. In this process, there would be defined state of the art is an amine washer, and the limits resulting of using an amine washer is below 5 milligrams. This is then state of the art, and all foundries have to be at least using this minimum technology to be within the limits. So in our case, if England would be still in the EU, all the foundries would be forced to use amine washers and reduce their amine levels. So finally, we have then a BAT reference sheet, a BREF document, in which this standard is defined. And based on this BREF document, you define the requirements, which then gives in the national approval law. In Germany, it's a BImSch, Bundesemissionsschutzgesetz. This is TA Luft, which is then the order for foundries and government with actual values. And then finally, you can find your value for the VOC. In Germany, it's below 150 milligrams C from now on, from the 1st of December last year. And then also there's defined 50 milligrams to reach within the next 8 years. So these are quite low values. But not only in Germany we have emission values and limits, also in other countries. A few fast overview about a few countries. In this case, for formaldehyde, which is also a VOC. Now we have here levels of the so-called AGV or the occupation exposure limit, which is the value for the workers which they are allowed to breathe within 8 hours. But anyway, you see that several countries, Australia, Austria, Belgium, Canada, so all the countries have values and problems and limits with their emissions. It's only part of the complete list. I'll show you later on the complete list. So emission is a relevant factor for all the countries worldwide. Here you see very small numbers, but this is a complete list worldwide. And you see that in Germany, we have quite low regulations, so quite low values which are allowed. These values, in a lot of cases, will be transferred into EU law, other way around, and will be adopted in national guidelines also in Australia, Finland, France, and so on. So Germany has here a leading role in this process. Emission behavior is more or less relevant as an economical factor. If you have no state-of-the-art technology in automotive area, for example, you're not allowed to deliver anymore. Let's say lead, for example, in the past, there was a definition, all the automotive defined no lead anymore in the process, and you're not allowed to deliver anymore if you're not completely lead-free. In this case, emissions, VOC, will be sooner or later a limitation from the suppliers, from the customers, from the customers, from the automotive producers, which then define what is allowed and what is not allowed. So it's an economical factor. So what is VOC in definition? What does it mean? VOC is a volatile organic compound. So all organic substances which are used during the casting process, which has a vapor pressure above this pressure, 0.08 kilopascal or more, at room temperature, 20 degrees centigrade or 293 degrees Kelvin. Or they are volatile under conditions where they're used, for example, in the drying oven. So all the organic you put in the sand mixture or in the process can be released sooner or later. And depending on their vapor pressure, they're relevant as the VOC in the process. The value you have to look at is then the total C amount. This is what usually is measured to define at what level you are at the moment with the VOCs. In Germany, we have the limit of 150 milligrams. And in 8 years, there's already fixed that you should have 50 milligrams. And it's a quite low value. Where does these VOCs coming from? A few examples. In a process, you use amine in the cold box process for gassing to produce the cause. It's a curing agent. It's leading to VOCs. You have also in the area of coating, ethanol or propanol, alcohols. These are VOCs. You have tetraethyl silicate or petrol as a solvent within the binder. These are VOCs. So you have in several areas, several sources for VOCs, and there are a lot more. Release agents, additives. So nearly in every area you will find those VOCs. So next question is, how can we measure these VOCs? So here is an example. On the left side, you have a classical core shooter from Lüber in this case. Then you see the venting pipe or the exhaust pipe. And then the black tube here. This is a measuring line leading to this measuring aperture, so-called FID, flame ionization detector. With this thing, you can measure automatically VOCs, the value total carbon. Every second you get one value, and it's self-calibrating. It's used also by government in Europe. Same technology. So this is a diagram you get when you use this FID. So this is a test we did in our pilot plant. First is the calibration. You use a standard gas, a defined concentration of gas in the air. So you calibrate with this. Then you have two peaks where you use during the gassing process only the amine, no sand, no binder, to flush the air, the lines. And then you have in the process 5 times a complete curing process. So binder part 1, binder part 2, sand, mixed, shot, and then gassed with amine. And this is the level of total C on the exhaust side of the core shooter. So this is one test for one binder. When you use another binder, you can see again the calibration here. Then the two peaks for the pure amine, in this case higher than this one because this binder needs more amine for the same strengths. And then 5 shots, complete process again, part 1, part 2, sand, amine, and this is then the level of a normal process. And you see the difference. There's 2 different binders and completely different total C levels on the exhaust side of the core shooter. So by choosing the right binder, you can reduce 64% total C already during the core making process by choosing a different binder system. With a high reactive binder and also with a reused amine, again, due to the reactivity of the binder. So let me give you, but these values are from the lab state, so from the pilot plant state. Now we have examples directly from the customer where we've tested the same 2 binders at the customer side. So this is a small sketch of a process. So you have here in a row 6 core shooters. Then here is exhaust line, and we chosen this measuring point as a summary of all 6 core shooters. Then we have here the drying oven. This is a continuous drying oven. And here's the core storage area and the core assembly area. But now for the next slides, we only look at this measuring point where we've measured the emission which are produced during the core shooting process. So this is such a diagram. The values from one shift, you see that they are somehow going up and down due to problems at the core shooter, for example, or a pause somewhere, or changing the program. So this is a normal variation over one shift. You see the orange line, which I put in for a hint where we have to go. 50 milligrams is the target, and this line is representing those 50 milligrams we have to reach in 8 years. So again, a normal production, one complete shift, 8 hours. So this is with a serial binder. Now we take the other binder, which we need less amine and which we have less VOC emission. And you can see here, again, the orange line at 50 milligrams, that the value is significantly lower, only by switching from one binder to the next. So to keep in mind, 50 milligrams is the value in 8 years, and actual is 150 milligrams. So actually, you would allowed to use this binder, but within the next 8 years, this one here would be a problem because the emissions are too high. But if you switch to the other binder, you're within the limits. No process change, only binder change. Now we take another measuring point. This is a drying oven. So we heat the produced cores to dry from the coating. So again, a diagram of the total C values. And on the left side, with these values here, we have an empty oven. Question is empty oven, and you have already values. Why that? Because this oven is heated with gas heaters, and the gas heaters, if they are not well adjusted, they can release propan or butan, and this can also lead already to a VOC value, a total C value, which is definitely a problem. So this is an empty oven, no core in the oven, nothing to dry. Then we use every position in the oven and put 37 pellets in the oven, so 37 cores. And you see that the values are going up. It's clear because you have additional emission from the binder itself and from the drying process itself. This is a serial binder, and you see, normal, more or less normal behavior. Values we look closer later on. So this is a secondary binder where we use less amine, and which we found that is more environmental friendly, less total C values. Again, this is an empty situation. The oven is empty. Then we fill the oven. All 37 places are full, and you see that the value has changed, but not that much like with the other binder. Again, the values we look next slide. So this is a summary slide for the values. So we measure the serial binder. Complete full load, we have a value of 60. With the other binder, the secondary binder, EcoQ Blue in this case, we have 32. I take these values and put this in the table below. So measuring result at the oven, total value we find. Then we take the values from the empty oven. Day 1, we have 26. Day 2, we have 25. So more or less on the same level. I transfer these data again in the table down below. Now I can subtract the total value minus the empty value, and then I get the value of the real binder. And then you see the difference. The serial binder, I have 34. With a new better VOC behavior, I have only 7. So a reduction of 78%, which is significantly better. So no change in process, only change in binder from one to the next. So, but you have to be aware that you have already here in this area values which are coming from the drying oven itself, so from the process itself, not related to the binder, only related to the equipment you have. And this is something you have to take care of. Let's adjust your burners. It's quite important because you're producing VOCs which are not necessary. If you have limits, they will be already hard to reach. And if you have 26 coming from the burners which are not necessary, this is a value you can put in the binder. Let's explain like that. So look closer at your burner and the adjustments. So technical solutions which you can use already. So first would be reduce your binder level to a minimum in your process. Because if you have less binder in your process, it's clear you have less organic in the system, and this means less emissions. On the other side, you reduce your costs. And even more, you reduce the gas pressure during the casting process, which reduce maybe gas defects, which are coming from gas pressure, which is produced from the binder or the amine. So this is first step, optimize your process with your already used binder. Second, use a binder with higher boiling solvents. This means you've seen at the beginning definition of the vapor pressure. If you if you use substances with which higher vapor pressure, so high boiling solvents, you reduce the emission which is set free, so you have less odor in the core shop and thereby less VOCs. At this point, there's a quite easy way you can personally detect if you have VOCs in your process or not. Use equipment you already have, your nose. If you smell something, you have VOCs in the air. If you have less smell, you have less VOC. It's quite easy. So with high boiling solvents, the solvents are not released in the air and you have no smell in the air. Then reduce your amine consumption. I've learned during visits at the customer that a lot of customers trying to increase their amine level to a maximum because they want to increase their curing speed. Yes, increasing amine will increase the curing speed, but if you optimize your process, it's not necessary to increase the amine. And amine is definitely also a VOC and can lead to a lot of problems if you're forced to be within the limits. And amine is definitely smelling, so optimizing your process, reducing the amine, it will lead to less odor and less VOCs. And for sure, at the moment, one very important point, you can reduce your costs because amine is getting expensive more and more. Then you have the drying temperature. If you in the process have to use drying process, reduce your drying temperature to a minimum. In a lot of cases, let's say 150 degrees centigrade with a more or less modern drying oven is not necessary anymore. 100, 110, 120 degrees is more than enough. And if you have a temperature where the core is finally then dried, that's enough. You don't have to heat more. When you heat more, you release the solvents at a point in the process where it's not necessary. So reducing the drying temperature will also reduce the VOC level. And on the other side, if you reduce your drying temperature, you will also reduce the release of VOCs from the gas barrier. And this reduce the VOCs and also reduce the costs, especially gas. You know the theme about gas at the moment. It's expensive and it's getting also expensive even more. So reduce your drying temperature to minimum. That will help everyone. Next thing could be also to switch to another release agent. A lot of release agents in the market are still on VOC-based solvents. There are on the market already water-based release agents or release agents on non-VOC solvents, so high boiling solvents. If you change to these, you can also reduce your VOC level. So let's talk about different binders. Let me explain this table. So this is a bar of relevant VOC, so a relative index. So this is a binder with a low boiling solvent. Low boiling, like Solvesso, like petrol, which are common on the market. You can use thermal oxidizers. Thermal oxidizers, why should I use this? Because at one point in time, you're not able to reduce the binder even more or reduce amine, and you have still emissions from the organic system. And if you have to stay within the limits, maybe at one point in time you are forced to use a secondary action, a heat treatment for the air to reduce your total C. And this is not possible with every binder. In this case, with this low boiling solvent, it's possible. So next line would be OEL level. This is odor and emission level. The best is the higher the value is, the better the behavior is. So it's not harmful. The lower the value, the more harmful the system is. So in this case, we have 100 milligrams per cubic meter as a limit in the area where the workers are working. Then you have the amen consumption level. We've learned that amen is relevant also for VOCs. So having a system where you are able to use less amen is better for VOCs level. And here you find the names of the ASK products which are in this range. So here we have another system, the so-called tetraethyl silicate solvent. So first problem is heat treatment here. You see it is not possible because when you burn the system, there's a silicium dioxide formed, and your exhaust system will sooner or later blocked with this silicium dioxide. So this cannot be used in combination with a heat treatment. On the other side, you have a lower OEL level. So we find here 12 milligrams, as I explained. If you have lower values, the substance is more hazardous. Third withdraw here is that you have a situation that the solvent itself already consumes amine, so you need more amine to cure this system. Anyway, there are benefits from the system. The raw material you use for this binder is, for the solvent at least, is non-oil based, which is at the moment a benefit when you look at the oil prices. So this is completely different price base than the petrol or biodiesel based binders. And you have definitely a low fume formation during casting. So if you have big castings or bad equipment, could this be an option? Then we have so-called high boiling solvents. With the high boiling solvents, you see that the VOC index is significantly lower. And again, you're possible to use secondary tree heat treatment to get rid of the final total C emissions if it's necessary. The solvents is completely harmless, so no limits are defined for the solvents. And you need only a low amount of amine for these binder type. In our house, it's called EcoCure Blue. It's a platform of binders. And then an outview for the future. We have new binders in the pipeline, which are based on inorganic solvents. Inorganic is not a precise definition, but let's say the content of carbon is significantly lower than in the other systems. So with this system, because it's high boiling and the most of the solvent is staying in the sand, we also, again, possible to use secondary heat treatment. We have no limits for this solvent because it's not volatile. But we need a little bit more amine than with the high boiling solvents or with the low boiling solvents. At the moment, there's no name for it, but it's coming soon, end of year. This would also be accessible. So let's come to the conclusion. So first thing could be to optimize your technical conditions. That's a quite easy way to reduce VOCs. In the most cases, you have no costs here, so you can lower your temperature in the drying oven. It's only time you need to optimize your process. Optimize your gas burners. So ask your equipment producer to optimize their gas burners. There are gas burners on the market which have nearly no emission, but you have to ask for it and let it adjust. And then optimize your curing process. Target would see less amen. Take time and look really close. If it's necessary to use this big amount of amen to be optimal in your process. Reduce amen, then you will use already VOCs. All these parameters, these ideas are not costing anything, only to the time to optimize your process. Next thing could be to choose the right binder system. Try to think about a more modern system, for example, with high boiling solvents. This platform, this AQQ Blue platform I've talked about, is mainly driven that we don't want to have phenol anymore, formaldehyde anymore, so there's no labeling for those modern systems. And even more, we have a lower amen consumption due to higher reactivity. So this could be a big benefit for reducing VOCs in your process, as you already seen in the diagrams I showed. And then reduce your binder addition level. This is a thing you can also do your own with your already used binder, or in addition with part 2 here, choose binder system. So finally, if you use less binder and less amen, you will have a cost reduction in your process. And this will significantly lead to a lower VOC level in your core shop and drying oven. So far so good. I'm through, and if you have further questions, let me know.
Yes, please write the questions on the below right in the chat function. I already see a couple of questions. Are you prepared, Frank?
Yeah, I see the questions, starting with the first one.
Yes, let me see. I've read that AQQ Blue was a VOC-free binder. Is that not true anymore?
This is a quite strange question because, as I already explained, let me go back to the slide. Wait, where's the slide? There. So VOC is defined like this here. We have vapor pressure, and with the AQQ Blue I've talked about, this vapor pressure is quite high. So in this state, at 20 degrees, we have per definition no VOC. Then we have a second area, volatile under conditions of substance used. This would be drying process, for example. In the drying process, you have higher temperature, and you're mobilized your solvent, which are stored in the core. So a part of the solvent will then be released. But anyway, if you use binder with VOCs or no VOCs under these conditions, you will have reduced VOC in your complete process, completely free of VOC. When you use an organic binder, it's not possible. Somewhere you will have emissions in the process, but you can try to reduce it to a minimum. And this is our target. Okay.
Okay, one more question. Can ASK provide certified measurements?
No, not in the moment. We can support you with this equipment here in our pilot plant. And this equipment here, this FID is mobile. We can bring it to you and can do a quick test at your site to see if you have actually a problem, and give you a hint starting from this point, from this value, what to do, how to improve according to the summary I already showed. So question is, are we certified? No, we are not certified. Is this equipment certified? Yes, this equipment is certified, but we are not allowed to give you an official certificate for VOCs.
Okay, then one question. Wait, I can't read it. I have difficult to see it here. In which way can be compared EcoCure Blue to IsoCure Focus 350 650 system? Is this one closer to EcoCure Blue or to EcoCure Silver in your VOC graph?
This is a good question, but closer means are the solvents more or less? Let's wait. I go to the diagram. So to find this Focus 350, 360 in this diagram, you are between this gray one and this blue one, somewhere in between. So this table here is only a black and white table. There are a lot of resins which are mixtures of low boiling solvents and high boiling solvents. In this case, 350, 650 is a more or less older system with a solvent package of both low and high boiling solvents, and is definitely not a phenol-less and formaldehyde-less system. So your question, I would say, a little bit more in the direction of EcoCure Silver. For all the others, EcoCure Silver is based on the platform EcoCure Blue, so this blue binder here, but we've chosen this system here, EcoCure Silver, for systems where we want to prevent condensate, for example, die casting. In die casting, we use these solvents because they're not forming condensate. This binder here forms condensate, which is for die casting not a good thing. Okay.
Okay, then one more question. What is the cost reduction in the process and the upper cost of the binder?
Yeah, you need, I think you mean a comparison between how much can I reduce cost by optimizing the process in relation to more cost for the binder. To be honest, it's complicated to answer this question. We have customers in which we've done a concrete price calculation per core, and starting with the actual binder level, introducing the new binder, optimizing the process, binder, additive, and coating, we finally were able to reduce the total cost for the core 25%, about 25%, with the same and better casting results, and with less VOCs. So yes, you have to pay maybe a little bit more for these modern systems, but if you look clearly at the process with a target to optimize your process, finally you will have a reduction of the total costs.
Okay. One more question. What is the modification of VOC content after pouring?
Yes. Clear, everything you put in the sand and in the process will at some point in time show somewhere in the process. So our idea was to reduce VOCs in the production area and also in the drying process area. And we are then bringing the carbon to the casting process. Yes, we are changing the behavior during the casting process. So producing more fumes with this high boiling solvents, and we're producing a different type of condensate. But our experience is that it's not a negative effect if you have a well-functioning venting system. You will always have condensate, but the type of condensate will change, that's sure, because due to the high boiling and low boiling solvents. So different boiling points means different behavior during the casting process. If you have the question in relation to will we have some gas defects during casting, the answer would be no, not significantly. Means you will have a change in process, yes. But our experience with customers, we have only 1 or 2 customers which have problems with gas defects. All the other customers, and we have a lot of those which are using those modern systems, have no problem. Changing the binder system will always lead to the need of looking closer at the process. If you're lucky, you don't have to change anything. If you have a specific process, maybe it's necessary to change parameters, and in this case, for sure, ASK will help to find the optimal conditions. Yeah.
Okay,
Next.
thank you. Right. One last question I see. Is there a known best available technology codebox product in Europe?
Yes, let's say, depending, you see those 4 binder types here in this graph. Depending on the conditions you want to use the binder, there are specific optimal binders. Again, for die casting, you are not able to use the blue one here because you're building condensate and your die will be polluted with the condensate. So you have to use this low boiling system. If you have big cores which are producing under normal conditions a lot of smoke, maybe this one here is so optimal. But all these systems you find on the market right now, or state of the art from ASK, is phenol free, formaldehyde free, in the best case label free, like here in the high boiling solvent system. So this is the state of the art. You cannot give one system, not one system will able to use in every situation. You have to look at the situation in your foundry, specific core, specific process, big cores, small cores. So you have to choose the right binder. And even with AKQ Blue, you will have, or AKQ Silver or Silver T, you will always have a portfolio of products, different part twos to adjust bench life or so on. So there's no specific best of binder. It's depending on the process.
Okay, thanks for your question. Thanks for answering, Frank. Before we finish, I would like to show you an overview regarding our digital services. All online, you can see the ASK product finders, find the right product for you faster, ASK white papers and technical papers. Ask the expert, it's a forum where you can ask specific technical questions and our experts will answer them. And online academy, this is where you will have access to this webinar, but also to other webinars. Okay, we are at the end of today's webinar. We hope this was a valuable hour for you, and we provided you a good overview about the topic VOC and potential solutions on how to reduce the related emission in your foundry process, including different solutions or offerings from ASK on how to efficiently reduce the VOC emissions. Feel free to contact us if you have further or more detailed questions regarding this topic, or if you would like support on an actual project which you are currently conducting related to VOC emissions reductions. Thank you for your attention and participation. As mentioned before, you will receive a link with the recorded webinar so you can review it if you would like, or some colleague of you would like to see it. Thanks again, and we hope to see you soon again online at another webinar, even more preferred in a personal meeting. All the best from Hilden. Goodbye.
Yeah, also thank you from my side. Goodbye.